Hi, today we are going to tackle a simple bubble sort in Python, and we're just going to do an ascending sort on this list of 10 random numbers between 1 and 10. So we are going to start by just talking about the principle of bubble sort. So the idea is that larger numbers will bubble up towards the top, and the smaller numbers will sink down towards the lower end of the list. Um, so the core function behind bubble sort is that we're going to look at the index. We're going to go through the index of the list. So we would start at index 0, then go to 1, 2, 3, 4, 5, etc. up until 9. And what we do at each one is we want to compare the number of the current index to the number to its right. We want to ask the question, is the number at the current index greater than the number to its right? If it is greater, we want to swap them. If it is lesser or equal, then we want to leave them alone. So the basic idea would be, if we start at index 0, we ask that question, all right, is 6 greater than 7? No. Is 7 greater than 6? It is. So we'd have to swap this. And what we would do is, we would just say 6 and 7. This is if we were doing a manual bubble sort, all right? Now, of course, we aren't doing a manual bubble sort, we are writing code. So the way that we would write out this core piece, which is just checking a number at a given index and checking the number to its right, seeing if the number at the current index is greater than the number to its right, swapping if that's the case. So we would say if r j is greater than r j plus 1, we're going to swap those numbers. Okay. So as we know, though, we need to do this at every index. So we are going to need at least one for loop to do this right. So we're going to say for j in range, and then we're actually going to take a quick second here and define the range that we want to do this in. So we're going to say n is equal to the length of our array, which is 10, minus 1. The reason we want to do the minus 1 is that, as we said, we're comparing the number at each index to the number to its right. When we reach the 9th number, we can do that. When we reach the 10th number, we can't. There's nothing to the right of the last number in a list. So we need to shave off one number so that we're not trying to compare the last number to something to its right, a number that is not there. So we're going to say for j in range n, if the current number is larger than the number to its right, they need to be swapped. Now, we're actually going to want to stick this inside of a function. So I'm going to go ahead and define bubble sort. I'm actually going to set this to array so that not just our list, but any list can be passed into this function. So we're going to move all of this to the right. Well, that's not it. Move all of this to the right. And we're going to actually switch all of these to array. Here we're going to put return. We're going to return our array. Now, as you can probably guess, something is a little bit off. A single for loop is not going to finish sorting this. But let's print it right now and just see what we get. So in order to do that, of course, we need to actually do an instance of this. So we're going to do an instance of our list of 10 numbers. And we're going to run it and see what we get. Uh-huh. Okay, here we go. So if you'll notice, a couple things have changed. So we now have 6, 6, 7, whereas opposed to we had 7, 6, 7, 6. A couple of the numbers have changed, but we'll notice that the highest number is now at the end of the list. This list is clearly not yet sorted. So in order to guarantee that well, let me back up a second. It's clear what we need to do now is we need to loop through this list multiple times. So what we're actually going to do is create a nested for loop. So in order to do that, we're going to say for I in range n, and then we're going to move all of this in to the right. And what this is going to do now is we are basically saying, all right, we have 10 numbers. If we loop through this list 10 times, because each time at least one number is put in its proper slot, we are guaranteed to end up with a sorted list. So this allows us to loop through the entire list until it is sorted. And as we will see, we will have, we'll finish getting the list sorted, and then it's actually going to run through the for loop a couple more times. So let's try this again and see what happens now that we have a nested for loop. We have the return too early. Now, notice we're only printing once, but here we have a sorted list. This is great. It took about 0.1 seconds. And this is a completed bubble sort. So if you can do this, as you can see, it will work every time. Run it again. You get the same sort. Took a little bit less time. Now, this is completely fine if you have a small list. But if you are sorting a very large list of hundreds or thousands of tens of thousands of numbers, there's a little bit of waste. And I will show you exactly where that is. So if we move this print to here, so it's inside. So this time, every time we loop through the entire list, we are going to print out the array and see what's going on. So let's print it out and see what happens. All right, so this first time, we've got 10 in the right place. Now we've got 8 in the right place. We've got the second 8 in the right place. We've got the 7 in the right place. We've got the 6 in the right place, the second 6, the 5, the 3. Wait a second, though. We've looped through it twice, even though the list is sorted. So that's not a problem on a small scale like this, but you get larger lists, and you are wasting a lot of time running through the list unnecessarily. So we're going to introduce 2 ways to make this bubble sort a little bit more efficient. The first one is here. So rather than just doing in range n, we're going to say in range n minus I. And I, if you remember, is this outer loop that we are doing. And the idea here is that every time we run this sorting action on the entire list, like we talked about, you're guaranteed to have at least one number in its proper place. So the first time you run through the list, the top number will always be in the last spot. The second time you run through the list, the second to last number will always be in the second to last spot. The second to highest number will always be in the second to last spot, excuse me. And so basically, once we have this in its proper spot, we don't need to run the process on this number anymore, on the second to last number, because there's no need to compare the number to its right because we know it's going to be higher. So what this does is says every time we run through the list, we're going to check one less index. So over time, what we're actually going to do is we're only going to be checking, we're going to check all 9 the first time. Remember, we're never checking the last number. So we're going to check all 9 of these the first time. And then because the number is 0, we know that we started with 9 because of this minus 1 up here. We're going to check 9 the next time. we're only going to check 8 because 9 minus 1, we're now at the number 1, you're only going to have 8. And the next time it's only going to be 7. The next time it'll only be 6, etc., etc. So you're checking fewer and fewer numbers because the numbers higher than that are automatically in their spot. That's going to save you some time. The other one that's going to save you some time is actually introducing a counter. So what we're going to do here is we're going to count the number of swaps that occur, and we're going to set it to 0. And every time that a swap occurs, because a higher number is being moved to the right, we are going to increment the swaps by 1. And what this is going to do is we can now say on this outer level, every time that the entire list is run through, it is going to count the number of swaps. Once the number of swaps hits 0, if there are no swaps, no changes are made, therefore the list is sorted. So what we can do is add a conditional that says if swaps equals 0, then break. So what you'll see is we've got a duplicate here. That duplicate is going to go away. So you'll notice this 3 was out of place, got bumped up, stopped printing. So this is, I believe there are a couple more ways to make Bubblesort even more efficient than this, but this is your basic Python Bubblesort with 2 little adjustments that will make your code more efficient. Join me for my next video, whatever it may be, probably on another sorting algorithm.